Featured in this session will be our nDepth 3D sensor technology and our nScan RIP scanning optimizing platform. While we're waiting for others to join, we have a short video showing our nScan RIP system in production. Following this intro video, we will dive a little deeper into these products and technologies. Lastly, we will open the floor for questions. Please feel free to post your questions in the chat area as we go along, and we'll try to answer those at the end. Thank you for joining us. Welcome to AikenControls. I'm Chris Aiken. I'm here today to show you a little bit about our nDepth sensor technology and also our nScan RIP product that's based around that technology. So just to give you a background, a little introduction to the nDepth sensor. AikenControls introduced this at IWF 2014, and we won the Challengers Award for this technology because this sensor, the nDepth sensor, is unique in that it's a full 3D color sensor. And how that's different from what you may have seen in the past with color cameras is that in addition to having a color camera inside of each of the sensors, we also have a stereoscopic infrared sensor pair and an infrared projector. And what that allows us to do is to measure the distance away that the product is from the camera. So for each dot or pixel inside the camera, we know we have an X and a Y and a color information, but we also have an X and a Y and a Z now in the color information. So for every pixel, we know how far away the material was that we saw. Now that allows us to do some things that are traditionally difficult to do with just a standard color camera. It allows us to find the material on the background very easily because we know the board is taller than the conveyor. So we can filter out all of the background, which is very important in processing because you have dust and dirt and sawdust and all kinds of other sundry things that fall on the floor in the chain, which are difficult to remove in many cases. So that's easy to get rid of. And they also can detect features in the board like wane that has no color contrast, gouges or holes that don't appear any darker than the surrounding wood. Okay, so that's the core technology that we're using. Now the nDepth sensor can see about a 3-foot long, about a 2-foot wide area at the mounting height that they're at today. And we can compose those together in order to form a very large virtual camera. So in the the test frame that we have here today, we have 4 sensors. We can measure up to 12-foot long material. But normally in production, we would have 6. So we could go from your shortest material up to 16, actually a little over 16, with about 17 is what we can see in production. And you can take the board and present it laterally. So if you notice, this board here is just resting against the pin stop. So if you've got a conveyor system today that's bringing material to in front of your rip saw, it's very easy to add this frame over top and have a full rip system. We can also do double-sided. So we have systems in production now that are doing double-sided at about 25 boards a minute. So what we do is we bring the board up, we shoot one image, we flip the board, let it come back, shoot the other image, and now we can process both sides of the board with top-only sensors, which is really nice. Okay? Okay, so let's take a look at what we're doing with this. So I'm going to come over, I'm going to scan the board. If you look at the board here, you see that we have some defects on it. We've got the knots, we've got some little pin knots, we've got this coloration, and we got a little hole here, pinhole here, maybe a few knots there. And what we're going to do is we're going to scan that board with the sensor array. So as you see on the screen, if you compare the board to the defects that were detected by the scanner, you will see that they're basically the same. Okay? We saw the large knots, the coloration, some of the pin knots, so forth and so on. And now we also can, just to have, so you have a look, you can see that we're capturing an image from each of the sensors. Okay, and we can support up to 8 sensors. Normally we have only 6 in the full system. And then we compose those sensors together and merge those sensors together to form an image of the board. Okay? All right? Now we do all of that, in this case, for nScan RIP, to be able to pass that information to the optimizer. And the optimizer allows us to create a solution for this board that's considering not just the width of the product, but also lengths. And in addition to that, also quality. So you don't have to have defect-free items in your cutting order. You can define a quality to allow certain kinds of defects and certain kinds of pieces, if you want, to improve your overall yield. So that's what's called quality RIP. So what we have in nScan RIP is a 2-dimensional quality RIP optimizer. It's taking the defects from both sides of the board and calculating the best solution for your product. So we also have some other things. You know, we have the ability to do loads, to keep track of load information for payables purposes. So we have tally scenario built into nScan RIP. We have the ability to sort strips and manage bundles or packs coming out of the nScan RIP if you're pulling the strips and making bundles. And printing technologies for sorting and lots of other goodies along the way. So hopefully we've generated some questions that you'd like to ask, and we appreciate you coming by. Hang tight, and we'll talk to you soon in the question and answer section.
Okay, thank you, Chris, for that demo there. And with that, we're going to open it up for Q&A. So if you have any questions, please drop those in the box below. And meanwhile, while we wait for questions to come in, I'll cover one question that we commonly get asked, and that's around reporting. What reporting options are available with the nDepth system, Chris?
Okay. So underneath nDepth, we have the nDepth and nScan RIP system. We have a full SQL database. So we record every board, we record every strip. So we can do yield reports, we can do distribution reports about what pieces have been generated. We can also basically work on load reporting. So as I mentioned in the video, we also, or in the demo, we also can accumulate reporting by vendor or by species and thickness, so you can get information which is important with distribution, length distribution, all of those standard kinds of things. So if we have captured it, you can do a report on it.
Okay, thank you, Chris. One other question we get a lot is, what are some other use cases for nDepth in addition to nScan RIP?
Okay, nDepth, since it is a sensor technology, can be used for lots of different things. So we can do inspections of panels, for example. which is really interesting because since we have the 3D aspect of the sensor, we can separate things even if they're the same color. So if you had a white panel laying on top of a white panel, we can see that top panel because we can filter it based on its depth. So we have panel inspections. We've done some flat pack inspection with it. So if you have RTA, ready to assemble furniture, and you're trying to validate something inside of a box, the nDepth technology is very, very powerful to do those type of inspections because of the 3D. We also have grade mark reading. We've got many different ways that we can use the nDepth sensor. So if you have an application where you want to measure something, bring it to us, and we think that the sensor probably has a chance to do it.
Okay, thank you, Chris. Another question is, what kind of accuracy can I expect with the nDepth sensors?
Okay, accuracy-wise is about 1 millimeter. So, and it depends on the height and the focal distance and size that we're trying to capture. So in this arrangement here for in-scan RIP, since we're 3x2 area, we have roughly a millimeter accuracy in raw measurement. So that's roughly what we hold in production. Now, if you have a special application where we're seeing a smaller area, of course, that resolution can improve.
Okay, thank you, Chris. What kind of production speeds can we expect with in-scan RIP?
Okay, in-scan RIP, we have double-sided at the 25 board per minute rate. Actually, just a tad bit higher. So for single-sided, it's really a function of how fast you can bring the material to the machine or to the scanning area. So upwards of 30 plus boards a minute on single side, about 25, 26 double side.
Okay, thank you, Chris. Just a quick time check. We've got about 2 minutes left. Any other general information that you're commonly asked that you'd like to provide?
Maybe about the lighting, okay? So the color camera requires a light. So a lot of people ask us, why do you need the LEDs? The reason we use those LEDs is to provide a nice uniform lighting arrangement so that we can find the defects using the color camera as well as the depth, okay? So you'll see that on most of the bars. Now, if you are only doing dimensional scanning, you're not interested in color defects, then you can actually use the sensor as is without any external lighting, because the color camera is what requires the lighting.
Okay. Thanks, Chris. Still got a minute and a half, 2 minutes here. Any concluding remarks or other information that you'd like to provide?
Well, first, thanks everyone for coming and spending the time with us today. If you have an application where you're trying to do an inspection or a dimensional gauging, please give us a call. We've got, in addition to the nDepth, we have lots of other sensor technology that we can bring to bear on your problem. So if you have an application that maybe you don't think is really suited for nDepth, please give us a call. There's tons of cameras and sensor technology that we implement and use inside of AikenControls. So with that, I'll say thanks again, and if you have any questions, please contact us. We'll set up a time to go through this in more detail or go through something specifically for your application. And just reach out to us either in one of the chats or send us an email or reach us over the platform, and we'll be happy to schedule a time. So thanks again.
Okay, thank you, Chris, and thank you everyone for joining.